Just look at this push button. When I'm pressing this push button only once, you can see sometimes the button pressed is printed more than once. So in this video, I will discuss why this is happening and what is the solution of this problem. So this problem is called push button debounce. So let's get started. Now let us discuss that why do push buttons bounce. So you need to understand that a push button switch is basically a mechanical switch and not a clean digital device like a transistor, which can switch on or switch off the circuit very clearly. And inside the push button there are two metal contacts, the upper one and the lower one. Okay. And when we press this push button, what happens? These two metal contacts don't touch each other smoothly in one go. And because of the mechanical vibration and sometimes due to loose connection, these two metal contacts hit, separate and again hit several times within few milliseconds. But the microcontroller is so fast that it can need the noisy transitions, and because of that constantly hitting and separation between these two metal contacts, we get this type of signal. Okay, you can see this is the high level of the signal and this is the low level of the signal. So when the button is released, the transition is from low to high, and when the button is pressed, the transition is from high to low. And in this blue region, the button is creating the bouncing problem. So when the button is about to press, it performs many transition between low and high states, right? Low, high, and after some interval of time, the button is outputting the stable low signal. So because of these so many transitions between low and high states, a single button press is considered more than once by the microcontroller. And this is the reason why we are getting button pressed printed on the serial monitor more than once. So this is the program that I'm going to use, and in this program the debouncing problem is not solved yet. After this I will also show you one more program in which the debouncing problem is solved. So the button is connected to pin number 3 and I am also defining one variable last button state is equal to low. And in the setup function the pin mode of button is defined to be input pull-up. And what is input pull-up mode I have already discussed in my previous videos. You can check out my channel. So this is the circuit connection for the input pull-up mode. You can see these two terminals of the push button are connected internally, and similarly these two terminals are connected internally. So this terminal is connected to pin number 3 and this terminal is connected to ground of the Arduino. Okay. Now the loop function, we are reading the digital state of the button and storing that state in the current button state. And if the current button state is not equal to last button state, it means there is some changes in the state of the button. Then we are updating the last button state with the current button state, right, for the next loop. And if the current button state is equal to low, then it means we have pressed the button. So why we are using low here? Because you see, when we will press the button, these two connection will get established, right? It means the pin number 3 will be connected to the ground and ground represent the low signal, right? That is why I am using here low. That means current button state is equal to low. It means we have pressed the button. So when you will upload this program on the Arduino and open the serial monitor, you will get this kind of output, right? And it might be possible that for a single button pressed, the button press is printed 2 times or even with 3 times, right? It may depend from button to button, and it also depends on how loose your connections are between the metal contacts of the push button. But we want to print this line only once for a single button press and not more than once. So we will tackle this problem in our next program. Now in this program the bouncing problem is solved, and you can see everything is same as before. Instead we are defining one more variable here called last time, and we are initializing this variable to 0, and setup function is also the same as before. The main changes are being done in the loop function. Here we have defined one more if condition, right? So if millis minus last time is greater than 50. So millis function gives you the time since the microcontroller started to run, and if the time difference between the current time and the last time is greater than 50. So what is 50 here? So 50 is basically the debounce time, and this debounce time must be greater than or equal to this interval from this point to this point, right, for which the push button is creating the bouncing problem. So 50 millisecond must be greater than or equal to this interval. Okay, if the time difference is greater than 50, then we are reading the digital state of the button, otherwise we will ignore this if condition. And if the current button state is not equal to last button state, then we are updating the last time with the current time and last button state with the current button state, and everything is same as previously. So when you will upload this program on the Arduino, you will see that for a single button pressed, the button press will be printed on the serial monitor only once and not more than once. Okay. So this is how we handle the bouncing problem of the push button. Now this time you can notice that the text button pressed is only printed once for each button pressed and not more than once. So this is the exact behavior that the push button is supposed to output. So our program is working fine. So if you really enjoyed this video, don't forget to like and subscribe and press the bell icon so that you never miss my latest video tutorials. And if you have any doubt regarding this project, comment in the comment section. And thanks for watching.